Welcome back to the Deep Dive, the show where we give you the shortcut to being truly well-informed.
Yeah.
Today, we're really getting into the engine room of, well, pretty much every modern company.
We are. We're talking about data. Specifically, we're going to do a rigorous analysis of how SQL is actually used in the wild.
Exactly. Our mission today is to move you beyond that basic textbook syntax, the stuff you learn in a tutorial.
Right. And show you how senior analysts in these big, complex corporate environments are framework for thinking analytically.
And by the end of this deep dive, you're going to have a much clearer picture. You'll get the real corporate data architecture where SQL actually lives.
You'll understand why data modeling can solve, I'd say, 70% of your problems before you even write a line of code.
We'll also cover the real-world difference between joy-ands in a textbook and joy-ands in a business report, the power of window functions, and, this is the big one, how AI is changing the game.
It absolutely is, and it's making these fundamental logic skills more valuable, not less. It's a fast-paced field, so let's just jump right in.
Okay, let's start with that big picture. Where does an analyst even sit in all of this? Because our sources make it super clear you're not just querying some random Excel file someone emailed you.
No, definitely not. You're working within a pretty sophisticated, usually 5-layer system, and if you don't know which layer you're hitting with your query, you can't be effective.
Why is that?
Because each layer has totally different rules, different reliability, different costs, different governance. It's crucial.
So what's layer one?
Layer one is your source systems. Think of your CRM like Salesforce, your company's web app, an ERP database. This is where all the raw transactional data gets created.
So it's messy.
It's very messy. It's the wild frontier, High volume, fast moving, full of typos and duplicates.
Okay, so then we need to clean it up. That brings us to layer two.
Exactly. Layer two is the pipeline. The ETL, or more commonly now, ELT pipelines. Tools like Airflow, DBT, Azure Data Factory, they move the data.
You said ETL and ELT. What's the practical difference there for an analyst?
Huge difference. Traditional ETL extract, transform, load meant you clean the data before it even got to the warehouse.
Okay.
But the modern approach, ELT, is extract, load, transform. We just dump all the raw, messy data into the warehouse first.
And then transform it.
And then we use the warehouse's own computing power in SQL, usually through a tool like DBT, to clean it and model it right there. It's just way more flexible.
Got it. So that brings us to layer three, the warehouse itself.
Yep. Your Snowflake, your BigQuery, your Redshift, it's the massive central library for all of this data, both the raw and the clean versions.
Which then sets up what you said is the most important layer for us, the listeners, layer four.
The analytics layer. This is your safe haven. It's built from the data in the warehouse, but it's made up of these beautiful, structured, business-friendly tables.
Facts and dimensions.
Facts, dimensions, aggregated views. It's the governed single source of truth.
So the big takeaway here is that senior analysts, the effective ones, they live in layer four. They're writing SQL against these clean, predictable tables.
100%. If you're spending all your time writing these monster queries against raw source tables, you're not really analyzing. You're doing a data engineer's job. You're just cleaning.
But I have to ask, you do sometimes see senior people hitting the raw tables, right? Why would they do that if layer four is so great?
It's usually about speed or cost. If they need some very specific one-off metric for an urgent question and it's not in the model yet, they might go to the source for a quick answer.
A one-time thing.
A one-time thing. But anything that ends up in a production dashboard, something the CEO sees every Monday, that has to come from the reliable, governed analytics layer, no question.
That makes perfect sense.
Yeah.
And it's a perfect lead into our next topic, data modeling. You mentioned the Kimball approach, the star schema. Why is that the non-negotiable backbone for all of this?
Because it brings sanity to the chaos. It introduces consistency and It massively reduces the complexity of the SQL you have to write.
How does it do that?
The star schema organizes everything around just two types of tables. You have fact tables and you have dimension tables.
Right. Facts are the numbers, the events.
The measurable transactional events.
Yeah.
Fact cells, fact logins, they hold the numbers, the amount, the quantity, and then a bunch of keys.
And those keys link out to the dimension tables, which provide all the context. The who, what, where, when.
Precisely. Your dim customer table describes a customer, but it doesn't have any sales numbers in it. And maybe the most critical one of all is the dim date table. It makes all your time-based analysis so much easier.
So for the person actually writing the query, what is the real tangible benefit? You said it removes 70% of complications.
It does, because good modeling basically solves all the tricky relationship problems and data duplication issues for you ahead of time. I remember this one analyst spent 3 days, 3 full days, trying to figure out why his sales numbers were tripled.
Wow.
He'd skip the model. He just interjoined like 6 raw operational tables together and accidentally created this huge multiplier effect. Every sale was being linked to 3 different events.
Whereas if the data had been modeled properly,
That query becomes a simple, clean join between one fact table and maybe 2 or 3 dimension tables. Done in minutes. You're querying clean structures, not raw chaos. It makes your life predictable.
okay, let's get into the mechanics of that query then. In school, you learn about all these joins, inner, left, right, full, outer. But in the corporate world, it seems analysts really only use 2.
Overwhelmingly, yes. It's almost always left join and inner join. And knowing which one to use it's a business logic decision, not just a syntax one.
So what's the rule of thumb?
Left join is your default for almost all reporting. We use it to, and this is key, protect behavior.
Protect behavior. What do you mean by that?
Okay, imagine you're building the main company revenue dashboard. You have to show every single sale, no exceptions. So you start your query from fact sales.
The table with all the money in it.
Yeah. Right. Then you left join out to dim customer and dim product.
And the left part means you keep every row from fact sales.
Exactly. Even if, say, a brand new product was sold, but the SKU hasn't been added to the dim product table yet, with a left join, that sale still shows up in your total revenue. The product name might be blank, but the money is there.
Ah, and if you'd use an inner join, that sale would have just vanished from the report.
It would have vanished. And you never, ever want to accidentally hide revenue just because some descriptive data is missing. An inner join is for when both sides must exist for the record to even be valid.
That one distinction is huge. Okay, let's talk about the other secret weapon for senior analysts. Common table expressions, or CTEs.
CTEs. They are absolutely how experienced analysts manage complexity. They let you take a giant 50-line monster query and break it down
Into logical steps.
into maybe 5 manageable, named sequential steps. It makes debugging and code reviews a million times easier.
Let's use that churn example we talked about. How would you use CTEs to calculate customer churn? Walk us through it.
It's a perfect example because churn isn't a single number in a table. It's a calculation. It's a multi-step process.
Okay, so step 1.
Step 1, we'd make our first CTE. We could call it, say, customer activity. Inside that CTE, we just look at the sales table, we grew you by Y customer id, and we find the max purchase date.
So for every single customer, you now know the last time they bought something.
That's it. That's step 1. Then we write our main query. This query selects from that first CTE customer activity. And this is where we apply the business rule. We use a function like daydiff to find the number of days between that max purchase date and today.
And if that number is bigger than your threshold.
Right. If it's more than, say, 120 days, we create a new column and we flag that customer as churned. If not, they're active.
So the logic, the business definition of churn, is built right there in the SQL, in these clear, readable steps.
That's the power, the most critical business metrics. They are born in SQL, in the warehouse, often using CTEs, not in the dashboard tool.
This brings us to what feels like the real dividing line between junior and senior analysts. Window functions. You say these are the true engine for advanced analytics. Why?
Because they let you perform calculations across a whole set of rows, a window, without collapsing them all down. A simple group E by Y smushes everything into one summary row.
Right.
Window functions keep all the original rows but add a new column with a contextual calculation.
So where are we seeing these pop up in real corporate dashboards? Where does that over clause show up?
Oh, everywhere. It's non-negotiable for things like running totals, rolling averages, ranking your top customers or products.
Year-over-year comparisons.
Year-over-year, month-over-month, absolutely. And for any kind of sophisticated segmentation, like putting customers into deciles or quartiles, you can't do modern analytics without them.
Okay, let's break one down, a simple one first. A running total of revenue over time. How does the window function do that?
So you'd write AM revenue over order by date. The key there is the order by clause inside the over. It tells the database the sequence. For each day, it sums up that day's revenue plus all the revenue from the days that came before it.
It builds on itself row by row.
Exactly, without collapsing the daily data.
Okay, now for the one that really shows you know what you're doing. The 30-day rolling average revenue.
Mm-hmm.
Let's dissect that syntax.
This is a fantastic one. The syntax looks a little intimidating at first, but it's very logical. It's often AVG revenue over order by date rows between 29 preceding and current row.
Okay, rows between 29 preceding and current row. That's the magic part.
That is the magic. You are explicitly defining the window. You're telling the database for any given day, look at this row and then look back exactly 29 rows. That's your 30-row or 30-day window.
And then it calculates the average just for that little window.
Just for that window. And as the query moves to the next day, the entire window shifts forward by 1 day. It's dynamic.
Now, what if I wanted that rolling average, but calculated separately for each sales region? The rolling average for Texas shouldn't include New York's data.
That's where the other hero clause comes in. Partition by. You would just add partition by region right inside the over clause.
And what does that do?
It tells the database to treat each region as a completely separate bucket of data. The rolling average calculation will run for Texas, and then when it hits the first row for New York, it starts all over again from scratch. It isolates the calculation.
So understanding that interplay between partition by, order by, and the rows definition, that's really the key.
That is the line. It's the difference between someone who just writes queries and a true analyst who can derive contextual insights from data.
So let's tie all this together with a real corporate use case. Cohort analysis. How do CTEs and window functions come together to build a cohort retention report, which is something so many businesses rely on?
Cohort analysis is absolutely vital for any subscription or e-commerce business. You're basically tracking groups or cohorts of users over time.
So everyone who signed up in January is one cohort.
Exactly. And you want to see what percentage of them are still active in February and March and April and so on.
So how does SQL build that?
Well, first, you'd use a CTE to define the cohort itself. For every customer, you'd find their MI purchase date and just take the month and year part. We can call that acquisition month. That's their cohort.
Okay, so that becomes our partition by key later on.
You're one step ahead. Exactly right. Then, in the main query, you use window functions to calculate the retention rate. It's a bit of a complex one. You need to do something like count active customers first value, count active customers over, partition by acquisition month, order by retention month.
Wow, okay. First value, what's that doing?
First value is a window function that, for each cohort, grabs the very first value in the window, which is the total number of customers who signed up in that initial month.
So it's the size of the original cohort.
The size of the original cohort. And you divide each subsequent month's active user count by that initial number to get your retention percentage. SQL makes something that would be an absolute nightmare in Excel pretty straightforward.
That's incredibly powerful. Okay, let's address the elephant in the data room, AI. Specifically, AI SQL copilots. Are they just going to make all of this knowledge obsolete?
Not at all. In fact, what we're seeing is that they shift the hard work. The cognitive labor is moving from writing the code to validating the code.
It makes the human logic and the business context even more important.
So much more important. We're seeing a kind of 5-step workflow emerge. Step 1, the analyst gives the AI a complex business request, like find my top 10 customers by year-over-year growth in the accessories category.
As you provide the intent.
Step 2, the AI spits out a pretty impressive first draft of a query, probably with CTEs and window functions. But step 3 is where the human analyst earns their salary. They have to clean, correct, and validate that query's logic.
What are the kinds of mistakes an AI makes that a human needs to catch?
The most common one is using the wrong join. It might default to an inner join when deep business knowledge tells you a left join is required to not miss crucial data. Or it won't know that in your company's weird old database, a status of 7 means soft deleted and needs to be filtered out.
The AI doesn't have that institutional knowledge. The human owns the business context.
The human owns the context, the governance, the data model. Then, in steps 4 and 5, the AI becomes a helpful assistant again. It can translate the corrected query into plain English for your boss.
That's useful.
And it can help optimize the query, maybe suggesting a better index to make it run faster and cheaper.
So the message is pretty clear. AI writes SQL, but the analyst validates SQL. Your logic, your understanding, that's what matters.
That's the perfect summary of the future of this role. SQL is so much more than a language. It's the framework for analytical thought, for making decisions, for turning all this raw, expensive data into actual, tangible insight.
And that deep understanding of the structure and the logic, not just memorizing syntax. That's what is going to differentiate you in this industry, no matter how good the AI tools get.
Absolutely. And if you're wondering about the next step, where to take all this knowledge, start thinking about how these metrics we've built in SQL, the churn flags, the rolling averages, get used in the next layer up.
In the visualization tools.
Exactly. Think about dashboard construction in a tool like Power BI and how essential a different kind of data modeling and a different language like DAX is to building that final interactive experience for the user.
That is a powerful path for continuous learning. Well, thank you for joining us for this deep dive into the real-world application of SQL. If you found this discussion valuable and you want more practical insights like these, be sure to like, share, and subscribe to the Data Analytics and AI podcast channel.
Keep learning, keep exploring, and we will see you next time.